So today let's talk about speed and velocity. What is speed and velocity? And yes, so velocity and speed. So for example, let me make the space coordinates. The space coordinates. For example, okay, this is the what's not really. Let me make it a more clear way. For example, over here, they are my space coordinates, right? So we know that this is our x-axis and this is our y-axis, right? For example, we have a vector which is r over here. Mhm. For example, okay, this is our origin, or you can say this is the frame of reference. This is this is our frame of reference. This is our frame of reference, or you can say this is our origin, right? Right. Let's draw a vector r. Let's draw a vector r from this origin to this point. So this is our vector r1. Vector r1, right? So now this is vector r1. Now it has covered some distance, or you can say it has covered some displacement. It has covered some displacement towards this direction. Consider that, okay, this is our vector r, this is vector, okay, this is r1, right? Now the vector coordinate has changed. Like, for example, if you guys have studied the types of vector, or you can watch my previous video of vectors, the types of vector. A vector which shows your position from the origin point or the frame of reference is known as position vector. So this r1 is position vector, and now it has changed. Now it is from this. Now this vector is here. Now if this vector is here, now it is known as r2. This is known as r2, right? This is known as r2, and I'm naming this as, okay. So as you can see, the r1 and r2. So what is basically speed is how fast the space coordinates. So these are basically the space coordinates. Wait a minute. For example, this r1's value is r1 is equal to x1 and y1, right? These are its coordinates. And r2 is equal to x2 and y2. These are its coordinates. Right? These are its coordinates, right? Now, if it has covered some displacement with respect to time, for example, let me write the definition over here. I hope, okay, let's write the definition over here, that how fast the space coordinates change, or you can say how fast the space coordinates, or you can say the position vector, the position vector of a particle, of a particle of a particle relative to a fixed point changes, we call this as velocity. Definition, right? We call this as velocity. Now, what is this definition basically saying? That there is basically the change in the position vector. There is the change. Oh my god. There is a change in the position. There is change in the position vector. First it was here, and then it has changed with respect to time, right? Or I guess the change in displacement with respect to time is known as its velocity. Now, how fast the space coordinates or the position vector, these are position vector r1, r2 of a particle relative to fixed point changes, how it is changing with respect to time, that is known as its velocity. So we can say displacement. What is this? Say this like displacement upon time is as velocity. Then you will say, then what is speed? Basically, displacement distance upon time. Distance upon time is known as speed. Now, basically, what is the difference between, okay, and as you can see in this given diagram. Okay, here we have a nice diagram. Say speed is simply how fast you are traveling. The car is traveling at a speed at 20 meter per second. It is not relative to its direction. Here we see distance, right? Distance is a scalar quantity. So it means that speed is also a scalar quantity. It is a scalar quantity. But what about velocity? Velocity is speed in a given direction. Speed in a given direction. When we talk about direction, what does that mean? We are talking about displacement. So here the velocity is basically a vector quantity. Velocity is basically a vector quantity. Velocity is vector. Now basically we are having many kinds of velocity. If you can even understand, if you are able to understand this concept, then you are able to do anything. Now let's talk about um, now let's talk about average velocity. Now, what is average velocity? Basically, average velocity is the total displacement upon total time is known as total displacement. Where should I write this? Do we have some? We don't have back and forth over here. So we don't have fraction form over here. Okay, here again. Here we have the fraction form. Okay, right. This is basically the average velocity is I'm unable to write. Okay, let me write it. Total displacement upon total time is known as our average velocity. What average velocity basically, this is the total distance upon total time. Now, what is average speed? Average speed is total distance upon total time. Note one thing to note over here is that why am I able to write any other way? Okay, one thing to note is that when your motion is in straight line, when your motion is in straight line, then note one thing that when motion is in straight line, motion is in straight line, then your speed and velocity both are equal. Your average velocity and average speed both are equal. Then your average velocity and average speed are equal, right? When you are in straight line. But what, for example, if I say you that in our diagram in the given question, you have for the what is the formula of velocity, which is displacement, like what formula of average velocity, total displacement, and we will find total displacement by adding all type of displacement. So it is to, for example, d1 plus d2 plus d2 upon t1 plus t2. This is your average velocity. Now if I say you that the time is same, how you will find what will be the formula of this velocity. So basically what you will do, we know that okay, s is equal to, like, the speed is equal to distance upon time. Here we want to find distance. So distance is equal to s multiplied by t, right? So here we can easily write this t is equal to s1, or you can see v1. Basically we will say here v1 v1 t1 plus v2 plus t2. This is right. If and the time will remain same, t1 plus t2, right? Now we will cancel these both. The t1 will be cancelled by this, t2 by basically by this, right? Wait a minute. We have to find here the value of distance, right? And now what else will be left over here? Okay, now basically we know that now if we replace d with this, we got the formula d is equal to s multiplied by t. So when you write over here, we know that here what was the condition? Time is same. So it means t1 plus t2 is equal to t. So t plus t is equal to 2t. What will happen? We will cancel this. We will cancel this t with this t and this t. So what will be left? v1 plus v2 upon t. So this is the formula when, like, this is the formula when time is same. The formula is v is equal to v1 plus v2 upon 2. We'll discuss about another formula in my next video.